Hey, so welcome back, and this is another daily LeetCode problem. So today it was called last stone weight, and it's an easy level problem. It's a max heap solution for this actually. I think that's the most common way. I don't think anyone really solves it any other way. So that's what I did, was using a max heap. Now we're using Python, and they don't really have a max heap; they only have a min heap. But just by like negating the values inside the heap, you're able to actually kind of create a max heap. So it's a bit of a hack, but that's what everyone seems to do. And so what you're given here is a problem called last stone weight, and you're just given an array of stones, and these are the weights of the stones. And so you just have two rules here for this game that you're playing, where you just want to take turns and smash the two heaviest stones together. And so in this case, if you first had to smash two stones, it would be 7 and 8 because they're the largest weight. And so you just keep going until there's at most one stone left. And as you're smashing these stones together, there's two rules here. One is, okay, if they're equal, then they're just destroyed and you just remove them from this array. Otherwise, if they're not equal, you just take the difference, and whatever that difference is, you just insert that back into this array. Okay, so as you keep smashing, just based on this algorithm, it's just inevitably going to be that you only have at most one stone or like none at all. So yeah, so let's go ahead and implement this. What we're going to do is you first just create a new array here, because we don't really want to modify the input array, and we just want to negate all of the values just so that we're able to actually like heapify this array and turn it into a max heap. And so to do that, you just say convert this every stone to a negative stone. So for every stone in our stones array, let's just negate it and insert it into this new array. And then we want to heapify it, so that's just heapq.heapify. And we want to convert this array into a max heap. So from here, we just want to continue our game, and the end condition is when we only have at most one stone left. So while the length of our heap here, I think we should call this heap, like max heap maybe. Or since we're in Python, we should use the snake case, max heap. So while the length of our max heap is greater than 1, we know that, okay, we're still playing this game. And so, but at the end of this, we want to return 0. If there's no stones left, we return 0. So if the length of our max heap is 0, otherwise we want to return whatever is at the top of our heap, which I guess is really there will be only one thing, so we can just really just return like the index of 0 because there's one thing that will be remaining. Okay, and so while we have more than one thing on our max heap, we want to smash the two largest stones together. And since we converted this into a max heap, whatever we pop off from that heap, those first two things will be the two heaviest stones. And so just to keep the theme with the x and y variables, we'll use that. So x will be equal to the first thing that we pop off our heap, and you can do that using heapq.heapPop. We want to pop from our max heap, and then we want to do this again, but insert the second largest value as y. And so just to follow the rules of the game, we want to say, okay, if x is equal to y, we want to just continue on. We don't want to add anything to our heap. If these are the same values, we want to do nothing. So you could just type like continue here, but in this case, why don't we just say we don't, if they are equal to each other, we'll just reloop. Otherwise, we want to consider this case, and we'll just say, okay, let's just take the maximum value and subtract it by the smaller one. And so in this case, well, since x is the larger value, what we want to do is, I think they have it like this actually. I did it differently when I coded it, but just realizing now. So they don't equal each other. Then all we want to do is we want to push to our heap y minus x. That makes sense. And we need to specify our max heap. So we're pushing to our max heap this difference, and since we're popping off y first, that will be the maximum value. And then we want to take x. Now, one thing that I haven't fixed here is that we're doing a subtraction right now, but we've actually negated all these stones. And so in that case, what we're gonna have is we want to take the addition of this, and that will be the difference. And so we'll still retain the negative values here, but we just want to add them instead of minusing them, because it's all like the logic's all like inverted. And the other thing here is we want to take the absolute because we don't want to return the negative value of this. Let's go ahead and run that. Oh, I see we got a wrong answer. Let's print this out. So let's print out, so print y and x. -8, -7. So we added the, oh, that's why, is we don't actually want to add them, because if you add two negative numbers, it becomes a larger negative number. So we want to do minus. And double check here, accepted. Okay, that makes sense. And let's just get rid of that print statement and just do that. I think this all looks good here. Let's go ahead and try submitting it. And success. So yeah, that's the algorithm. So for time complexity, I believe, so since we're inserting everything into our max heap here, we're going to have a space complexity of O of n, where n is the size of the stones array. So space is O of n, and n is the size of the stones array. And for time complexity, well, that will be like nlogn, which is time complexity to heapify this. So it's nlogn for time complexity. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.